Today we're going to look at Unit 2.1, Part 2, which is exterior angles. So our objectives are the same as last time, except instead of looking at interior angles, we're going to look at exterior angles. So all of these should say exterior angles. So what is an exterior angle? I've got a diagram here. You can see that we get an exterior angle by extending one side and then measuring that angle that's outside of the polygon. So let's do a brief investigation. It says in each polygon, extend each side farther in one direction. So I'll do that. I would encourage you to do this also on your paper and see what it looks like for you. To make a straight line in Notability, I'm just holding down the stylus. And think about the pattern you're making when you do this work. Okay, so now we're supposed to find the measure of each exterior angle. And I'd like to remind you that the interior and exterior form 180 degrees. So here where I've got 108 on the inside, I'm going to subtract that from 180 to get the interior angle. So all of these are 72 degrees. Because 72 and 108 makes 180. Here, all of these exterior angles are 90. And on the triangle, all of them are 120. Now I'm going to find the sum of those exterior angles. In the Pentagon, the first one, I'm going to take 5 times 72, because there's 5 angles, and that's 360. On the rectangle, I'm going to take 4 times 90, because there's 1, 2, 3, 4. 4 times 90 gives me 360. And finally, in the triangle, I'm going to take 3 times 120, and guess what? It's 360. So the exterior angles theorem tells us that the sum of the exterior angles for any polygon is 360 degrees. So we're going to use that information to solve some problems. Here I've got a figure with 4 of the 5 exterior angles labeled. And basically what I know is that if I take x plus 40 plus 65 plus 60 plus 70, it must equal 360. So I've just added each of these in order. And now I'm going to solve it. So 40 plus 65 is 105, plus 60 is 165, plus 70 is 245. And I'll subtract 245 from both sides. And I'll get that x is 115 degrees. Okay, next one. I'm going to find the measure of one exterior angle of a regular octagon. So first I'm going to make a sketch of a regular octagon with exterior angles. And I actually think this is kind of fun, but I am a math teacher. Oops. So there's my octagon. It's got 8 sides, and here's an exterior angle. I know that the sum of the exterior angles is 360. That was the theorem that we just learned about up here. And I know there's 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. In fact, the exterior angles, the number of exterior angles matches the number of sides. So now I just need to do a little math. I'm going to take 360 divided by 8, and I get 45 degrees. And one thing that's kind of cool about this is you could also use it to find an interior angle. If this is 45 degrees, then I know that the interior angle would be 180 minus 45, or 135 degrees. And you might like to solve something that way. Let's try another one. Each exterior angle of a regular n-gon is 40. Find n. Well, we can see what we did up above was we took 360 divided by the number of sides, and we got the measure of one angle. So now I'm going to solve this. I'm going to use the skills that we used back in the trigonometry chapter. I'm going to multiply both sides by n, and it cancels. I'm going to get 360 equals 40n. And I'm going to divide both sides by 40, and I get that n is 9. So it's a 9-sided figure. Okay, here's another one. Each interior angle is 150. Find n. So this is where being able to draw pictures is helpful. We know that the interior angle is 150 degrees. One way we could solve this is to figure out what the exterior angle is. And since these add up to 180, that exterior angle must be 30. And then I can use the same process as I did in number 9. 360 divided by n must equal the measure of one exterior angle. And I'll multiply both sides by n. 360 equals 30n. So n is 12. All right, we've got just one more example here. Another algebra-based example. Here we've got a 6-sided figure, and we need to find y. And the sum of all of these is going to be 360. So I'll start with y plus 61 plus 2y plus 35 plus 50 plus 59. What we've learned and have been using is that the sum of all of those is 360. So now I will combine like terms. So my first like terms are y and 2y. So y and 2y are 3y. And then I will do something similar for 61, 35, 50, and 59. So I'm going to get out my trusty calculator. 61 plus 35 plus 50 plus 59 makes 205. And then I'm going to subtract 205 from both sides. y equals 155. So when I divide by 3, I get that y is 51.6 repeating. Can we have a decimal? Oh, yes, we can. Okay, so down at the bottom of the page is your homework, page 364, 23 through 31. Good luck.